Okay, go ahead, Matthew. Let's see if we
All
can keep
right.
this to less than 5 minutes.
It's like 5 minutes. Okay, so we'll just breeze through this then. So problem solving tricks are super important. Redstone is really hard, as Adam was saying. Like things can look really hard, but using these problem solving tricks, we're going to be able to break down our redstone really simple components and sort of make sense of what's going on and be able to build really cool and complicated stuff. All right. So first problem solving trick is to identify the problem, set goals. Uh, let's see. Usually I would ask if anyone wants to read this, but I feel like no one really wants to read this. That's because it's really long and, it's got a lot of filler, silly words in it.
It's
So
funny.
it is funny. Marcus, do you wanna read some of it?
No.
All right. Totally fair. Yeah. I think here the sort of message is you want to be able to filter out like all of the useless stuff. Does anyone want to tell me what the meat of this is, like what the real problem is? Marcus, I'm sure you know what it is. If you take out all the useless words, what's left over?
Build.
Mm-hmm.
Marching.
A machine. Yeah, good.
That earn money.
Yeah, exactly. So the problem here is to build a machine that earns money. Yeah. So I don't know if you guys have done word problems in school yet. I think back in the day, I used to hate those, right? But what what you gotta figure out is if you're able to like filter it down, those have a lot of useless words in them too. They might not be like gobble gobble oink, but they'll be like, Sally went to the store. So if you're able to cut those words out of whatever your problem is, it's gonna make it a lot simpler. All right, cool. So that's trick number one. Trick number two is to research and study what other people have done. So you want to be able to like build on what other people have done. Don't sort of like reinvent things. Like you might try and like figure out exactly how something works in Redstone because it's really cool. And that's totally fair. But I think instead of trying to invent something that someone's already done,
Is it a word?
on the right side, read it from the bottom to top. Yeah. If you look on the bottom left, you start there. So it's SUCCESS, spells out success. Yeah, and that success is built on other people's blocks and ideas. So yeah, basically we're just gonna look at things that people have already done. Like the AND gate has already been invented. We're just gonna use it to make really cool traps that are our own. Right. Trick number three is to organize a hotshot team and build teamwork. We are all in this class together, so we're able to look at each other's builds, provide feedback, and help each other grow and give each other really cool ideas for our own bases. Trick number four is to break down a complex solution into simple solutions. So, I mean, for example, kind of like what we've been doing, if you want to build a really cool lava trap, you're going to need an oscillator and a NOT gate. Those two things together, you can put in like one contraption, ends up being a lava trap. And trick number five is to document your progress. So that's why we have the lab book. I've used lab books for all of my other projects. They're super useful. They just help you kind of remember what you're doing and keep you on track. All right. So in summary, these are the 5 problem-solving tricks. Before we move on, if you guys could maybe put these in your lab books, sort of in the spirit of trick number 5.
In
I will.
101, we already do it.
Yeah. So that's why I went through this really quickly. I'm going to put these in chat. If you can put this on a slide in your lab book, then that would be ideal. All right. Does anyone have any questions on this? Anything I just said?
No.
Since we've already done this in 101, We'll give you 3 minutes to get this in your lab book.
Yep.
Okay, I'll start the clock. 2.5 minutes left.
Wow.
Time goes fast.
Indeed.
If you don't think you can get it all typed into your lab book, just copy and paste quickly what Matthew put in the chat box.
Yeah. Kevin and Adam, are you guys putting this in your lab books right now?
Can you show it again?
Yeah, it's in the chat. I can screen share it, but the tricks are also in chat if you want to copy and paste it.
Okay.
Cool. Kevin, are you putting this in your lab book right now?
I don't know.
你可以 type 这个 in your lab book，
Type.
就是他现在让你把这个信息打进来。
All right, cool. How about you, Adam?
Guys, if you ever want to be an engineer, if you want to study engineering in school, in college like Lucian and Matthew,
No, you don't want to be an engineer?
you've got to practice these
Yeah.
problem-solving tricks.
No.
Okay, 1 minute left, guys, to get this page in your lab book. In your lab book, you should have the cover, Minecraft 102. You should have definition of the problem and the mission. You should have average, ugly, and way cool way to present your ideas. And you should have problem-solving tricks. Sort of fundamental concepts that build yourself. In order to build cool stuff, this is the foundation.
Yeah.
Okay, 30 seconds, guys.
15
15 seconds. 14, 13, 11, 9, 6, 5, 4, 3, 2, 1. All right. Okay, guys, it's in the chat box if you don't have it. Lucian, so thanks, Matthew.
I think I will write it when this class is finished.
That's great. That's a good way to do it. Okay. Then you'll have more time to learn from Lucian and Matthew.
Yeah.
Okay, Lucian, shall we go into AND and OR gates again and see if we can put them together in an interesting combination lock or whatever you have in mind?
Yeah, exactly. So let me just share my screen real quick.
By the end of the class, Lucian,
All right.
what should we have? If you pay
So by the
attention-
end of the class, our objective is to be able to make a really, really cool door. For one, it's a really just cool door to have because it's completely hidden and it's a bigger door. It's a 4x4 or it's a 2x2 door. So it's 4 blocks total. So it's a little bit bigger than the doors that you guys have been making already. And also it's going to involve a combination lock. So you're able to actually lock it. And if people don't know the combination, they're not going to be able to open it. So what we're going to do, or what we're going to need, you can see on my screen, the tools that we're going to need are right here. So we need an AND gate. Remember the AND gate that we were talking about yesterday and the day before? I think actually every day we've talked about these, but that's just because they're super important. So you see this AND gate right here, that 3-block long little bar, that is an AND gate. Then we also have our NOT gate, which Memo was able to identify yesterday. We have that NOT gate. And what we're going to do is we're going to use both of these tools in order to create a really awesome door. So here is the schematic for our door. And when I say schematic, I mean, this is our design. This is our really, really basic map for what's going to be happening. So we're going to have inputs. Remember all of the inputs that I talked about earlier in multiple classes before. We have buttons, there's pressure plates, there's levers. We're going to be using levers for this. So we have 4 levers that we're going to use as our input. And you can see that we have 3 different AND gates. So we have one here connected to 2 levers, one here connected to 2 levers as well. And then the outputs from both of these AND gates are connected to another one. So that means that all 4 are connected to one AND gate through a collection of different gates that combine 2 signals into one signal. So we have that. And this, again, this is what we would normally call as like a circuit diagram. And this is really, really important when you're being an engineer, because you need to be able to show people exactly how all of your stuff is connected. And this is a really basic way and a clean way to show that. And it doesn't have any like frilly designs around it or anything else like that. It's really straight to the point, which is exactly what we need. You can see there's also an inverter here. That's the NOT gate. So we have a NOT gate here, and there's also a NOT gate here. But in the build that I'm showing you guys, I don't have this one here because I figured it'd be easier and more simple to just show you guys the most basic model of this door. So the way that this door will work is if you click one lever on, nothing happens. You put 2 on, nothing happens because only one of the inputs for this AND gate is activated. But if you actually end up getting to all 4 levers being flipped to the correct state, not necessarily just on because this one would have an inverter in this case, but if you have them all in the correct state, then suddenly this door is able to open. And the reason we have this inverter right here is so that typically a piston will only activate when it has redstone going into it. But we want them to always be on. That's what we've always been doing with our doors. We want the pistons to always be out, and when we activate it, it actually turns off, so it retracts. So that's why we're using an inverter here. And also, something that you can do is try to connect some kind of oscillator to it. So in this design, we have all of the stuff that I talked about with the triple AND gates and these inputs, and it still goes to open the door, but you can see the signal is also split and put into another AND gate that's connected to an oscillator. So now we're able to have a dispenser. You guys could have a bunch of different types of outputs here, not just dispensers. You could have lamps, you could have doors, you could have a bunch of other stuff. And now they'll be able to oscillate, but they'll only oscillate when everything in this door is activated. So what this ends up being is if I share my screen again and show you the Minecraft equivalent of this when it's actually built, you'll be able to see everything that I'm talking about. So right here, you can see like we're kind of in a little unassuming hallway. You know, you wouldn't really expect there to be a door right here. It's just a little, you know, stone wall. But what's actually happening is there's a lot of stuff going on in the background. You can see there's a real big circuit. And if you look at it from this angle, from up on the top, it looks the exact same as the PowerPoint that I was just talking about. You can see that the lines are all going the exact way that they were going in the PowerPoint. And that's because this is the real built version of what I had in my circuit diagram. So what happens here is if I flip one lever, you can see now we have an input here. This torch is now off, but nothing has changed. If I flick this one, now you can see both of these are off, and that means that this AND gate is active, which turns off this one. But you see, we still have to turn off this one, this torch, in order to activate the whole door. So you can see we have AND gate, and another AND gate. Then we have an AND gate here, which is connected to an oscillator. Remember, this was the first oscillator that I showed you guys. It's a really compact one made with just some repeaters. So now if I go here and I flick this lever, now we have this torch is off, but this one's still on. And now if I finally do that, it opens the door and we have all these fireworks shooting out. because that oscillator is connected here and this torch is off, meaning that everything is active. We have a signal coming over here getting inverted by this OR gate, which then deactivates this whole door. And we get a really nice festive, well, actually now we ran out of fireworks, but we did have a nice festive showcase of you being able to enter this door.
I love the solution.
Just one of these off, now suddenly it's back incognito mode. And now the way that you would make this really a puzzle, so like if you imagine that I'm like an invader, right? So I'm just some guy trying to come in, and even if I know that there's a door here, I might not think to flip all of these switches at the same time. Or if I do, it'll take some time for me to actually get the right combination. And what you can do is you can just set some of these in the down position, so it makes them think that maybe they have to flip all of them. But if they do that, then nothing happens, it's still off. So there's a lot of confusion that can happen here for people that aren't familiar with it, which makes it a perfect way to make a combination lock. You know, they could go through and try to flip one, flip another, flip another, flip another, nothing's working. They can try two. And you see, obviously it can take a long time for them to try to go all the way through and test every different combination, which makes it perfect for locking up your door. And it's a quite simple way to do this.
You know, now, I love this. I love this, Lucian. You know what would be a really interesting, nasty trick? What happens if someone tried the wrong combination and something bad happened?
Yeah, true. So what you can do for that is actually, you could potentially wire these. So it's kind of hard in the design that I've created right now, but an interesting challenge would be make the combination lock. Well, I think this is a challenge in and of itself, but if you guys are able to make this combination lock door, then also what you can do is essentially make a different combination that makes something really bad happen. So what you can do is I could wire some of these inputs. Maybe if someone activates this one and this one at the same time, I could wire these to a different AND gate. So, you know, this could come over here to an AND gate. This one, if I had spaced some things out differently, maybe I'd be able to make that go, let's see. Well, I might be able to dig down and just show you guys real quick. So what we could do is we could split the signal. So if we just move this lever
maybe
down
a simple solution would be just to add a fifth lever. And if if someone flipped that fifth lever thinking it was part of the combination.
True. Then you could have a quick trap lever that could just make something really bad happen. Basically the idea here is there's a lot of different ways that with this many inputs you can make so many different things happen, almost an infinite number of different things happen with different combinations. And you can use that to your benefit because you ideally are the only one that actually knows the right combination, and other people aren't going to know that, and they're going to really suffer because of it.
I love this. I especially like the touch of the oscillator driving the fireworks.
Yeah, it's a great addition because then you can have some really dynamic behavior, even though you're just flipping some levers.
You get a prize if you get through the door.
Yeah. So does anyone want to build this in? Well, I think we should all be trying to build this in our world because it can make a great addition to our builds. And you don't even necessarily have to make a door open with it. one thing that I've done before is I have created, let me just destroy this. I have done other things rather than just opening a door with it. I have made some platforms come out that you can jump onto. You can make like a trap door open. You could make just really any output happen. You could make even just a lamp turning on with your combination locks. And so that can be really useful because sometimes you don't necessarily want to have a door, especially since most of you guys already have doors in the first place. So what I would recommend doing here is building this structure first, building this series of AND gates that are connected to 4 inputs. And then once you have that, once you have your lock built, then you can figure out what you want to do. And if you guys want to build this cool door, I can show you how to do that. So does anyone, I guess right now, does anyone want to build this door in the end? Like, does anyone want to make this cool 2x2 door, or do people want to do other stuff with the combination lock?
A 2x2 door. I like that. Would it be possible to have a waterfall that stops when you do the right combination?
Totally. That's an extremely useful and simple kind of demonstration of that as well. That would be really cool.
I love the idea of the fireworks going off when you get the right combination. I like the idea of a reward if you're a friendly.
All right, so Memo, would you want to build this door, or would you want to have a different output? I just kind of want to get a feeling for whether I should walk through building this door itself.
I remember something that I see in a video that is mostly like that. If you put a button to have in a paper the correct answer, and with that paper in another you will open something that's, well, we will open the chest for another paper that or the chest that will help you to go out.
Nice. That sounds like an interesting puzzle right there.
So in the chest is instructions on how to navigate your labyrinth. Yeah. It's like a treasure map.
Cool. So what I'm gathering from that is you wouldn't necessarily want to build this door, I think.
No.
Gotcha. Cool. So Adam, Marcus, Kevin, do any of you guys want to build this door?
It looks too complicated.
Because we're all going to be building the combination lock, but it all just depends on what output we want to have. So we're all building this part, all of this redstone stuff. The only thing that I'm wondering is whether we want to build this part right here, the actual door itself. Or if we want to just connect something else to it.
It looks like too complicated, so I don't think that could do it.
Oh, I think that everyone here would be able to do it. And I'm going to walk you through if you want to. So it really just depends on if you want to be able to do it.
Okay.
So would you want to be able to build this door?
No.
No? All right, cool. So in that case, we're just going to get right into building this setup right here, the combination lock. And then you guys can connect whatever you want to it at the end. So does everyone have their Minecraft world opened up? Yes? No? Maybe? Maybe it's just loading or something.
I have it open.
Oh, sweet. Cool. So you have it open right now? Marcus, Adam, and Kevin, you guys have your Minecraft worlds open as well?
Yeah.
Open?
All right. Sweet. Cool.
Yeah.
So let's get to it. So everyone, what I'm going to need you guys to get is you're going to need to have a lever. You're going to need to have some kind of building block. I'm going to use, I think I'll just use this. This looks cool. Yeah, sure. So I'll use this wood. You need to have a lever. You need to have some redstone. This dust right here, the redstone dust. And you also need to have a redstone torch. And you should be able to build all of this stuff with just those materials, this whole triple
I'm
setup
in
right
class
here.
right now.
All right, you guys ready?
Yeah.
Sweet. All right, so what we need to do first, guys, you make a little wall, like a low wall. You can make it pretty much however wide you want it, but I would recommend that it's at least 8 blocks wide. And that's because we have 4 inputs and each one needs to have a little area of space between the others. So if we have 8, I'm pretty sure that should be fine. 1, 2, 3, 4, 5, 6, 7. Oh, 7 would be able to fit then. All right, cool. So it has to be 7 wide. So I'm gonna add one more right here. And you're gonna put a lever every 2 blocks. So you can see we have our 4 levers here. And then you need to put a block on the ground level behind each of them. Is everyone following along with what I'm doing so far?
Yes.
Sweet, cool. So then you put redstone on all of those blocks that you put, and you can bring that redstone down. And now you'll be able to see that if you activate these levers, you actually activate the redstone behind them. So when you flick the levers, you should see that the redstone turns on behind it. And if not, then there could be something going wrong.
Cool. Adam, if you follow Lucian step by step, it's very, very simple.
All right, so now that we have that, let's extend this out a little bit just to give us some room. So add some more redstone to these. Then we're going to start building our AND gates. So if you remember, an AND gate always has the same structure. So it's 3 blocks with a redstone torch on the far ends of each, some redstone dust in the middle, and then a redstone torch on the opposite side right here. So this is an AND gate. We're going to build 2 of those. So we have that same structure on this end. And we're pretty much already super close to being done. I'd say we're like 2/3 of the way there if we just have this. So then what we do is we put redstone dust right next to this torch that's on the side and maybe bring it in a little bit. So make a little L shape so that it's closer. And then what we'll do is we will make another AND gate with the redstone dust going in. So we have that same shape again. And that's it. That's the whole thing. This is a whole combination lock right here. It doesn't have any output connected to it, but this is the whole combination lock. Is anyone having trouble building this? Or is everyone doing well with it?
I will copy the image of here, but I'm good.
Sweet, cool.
I don't know how to go to build and I don't know how to when I'm building I still can see your screen.
Oh, yeah. So when you're building, you're not going to be able to see my screen. So you might just have to flip between the two. Are you saying that you're having trouble going between the two windows?
Yeah. I don't know how to make it same time. And I don't know how to go to my world now.
Oh, I see. So what you're going to need to do is, if you're in full screen mode, you're going to have to press the escape key. And that is the very, very top of your keyboard. If you go all the way to the left side.
Left?
It has, yeah, left. So it has
I and is it a green and inside have a tick? Or I see a round inside have an I and a green thing inside there have a tick. Now let me see this.
Are you looking at your screen right now?
Yeah, I'm looking.
Okay, so on your keyboard, so you know the keyboard that you type all your buttons into?
I didn't see.
It's not on the screen of your computer. It's the thing that you like press to like type words in and stuff like that. And like when you're moving in Minecraft, you're using the keyboard.
I didn't see anything.
Well, it's like a physical thing. It's not on the screen of your computer. It's like a physical thing that you touch. It's connected to your computer.
Okay. It's where?
What was that?
What's that button called?
It's ESC, so it's escape.
Oh.
But it's just ESC. Yeah, it's on the top left of your keyboard. Yeah. So if you press that, then you'll get out of full screen mode, and then you should be able to just minimize your window.
Yeah, but I still only can see your screen.
All right, so maybe if I stop sharing, then maybe you'll be able to just go into Minecraft, and then I can reshare and you'll stay in Minecraft.
I still don't
Or you can share your screen and I can help you build this while you share your screen. So if you share your screen and you make sure to click the two checkboxes when you're sharing your screen, there's two checkboxes when that little window pops up, when you click share screen, make sure that both of those are blue and check.
What was the last part of the mechanism?
Like here?
So the last part is that third AND gate. Remember, so there was two AND gates that connect to another AND gate.
Okay, thank you.
Mm-hmm.
I only want to see your screen and my screen. I don't know how to do that.
Yeah, so what you're going to need to do is you're going to need to be able to go between the two. So you're going to need to be able to go between Minecraft and Zoom. And the way you do that is by minimizing the Zoom application. So Can you minimize this window?
Now I know how to go inside my Minecraft world, but I don't know but if I go inside my world, I only can hear you and I can't see your screen.
Yeah, I know. So you would need to be able to look at my screen and then stop looking at my screen and look at your screen and build stuff just based on memory and just go between the two. Or you can share your screen with the blue boxes checked and I can just help you build it.
I know. I think I can build.
Cool. Yeah. So in that case, I'll just share my screen again so that you can see what I built.
Okay.
And try to replicate it.
I go into my world now.
Cool.
Okay. Okay, I'll do this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Down this.
And while Marcus is building, Adam and Kevin, how's the building going on your end?
It's okay, I guess. Well, like, I haven't built it yet. Well, I'm trying to like think about the idea.
Okay, so what part of it is confusing?
Well, like the code thing, but I'm starting to get it, and I don't really need your help. I just like need to test like more combinations.
Oh, I see. So you're trying to figure out a combination?
Yeah, I'm trying to figure out.
I see.
Good.
It might be better to just build it. I think it's easier to figure out combinations after you build it because you can always change this part. You can always change these levers. You can invert them after you build it, which makes it a lot easier. So like what we can do here is if I put a torch on the back end, then suddenly it's the exact opposite of what it would normally be. So I can pretty much make the opposite kind of stuff happen after I build it really easily. So if anything, I feel like you should build it first and then think about the combinations afterwards.
Okay.
All right, so we have another like 5 minutes in class, so we're gonna see if we're able to finish building these. And then the task for, I guess your homework for tomorrow, even though we wouldn't really want to call it homework, your mission for tomorrow is to connect this combination lock to something, anything really, on this end. So you can have any output. I would try to make a cool kind of thing happen. Maybe you can wire it up to some kind of, like for example, John was talking about having a waterfall stop. So I'll build that right now actually, just to show you maybe what that could look like. And if you guys have any questions while you're building this, don't be afraid to ask them, because this is probably one of the more complicated things that we can build, But even then, even though it's a complicated like end result, the pieces that go into it are actually quite simple.
They're weakened.
The waterfall door, I love it. Sweet, Lucian.
Yeah, so then you could, make like a whole kind of like pool of water happening here. And all of that, see, it's kind of just like a demonstration of how this same design can actually result in some very different styles of doors and builds and really anything.
Sweet. Guys, we have just a few more minutes. Anyone want to show off before we adjourn?
Me.
What you got? All right, Memo.
No, me.
That was Adam.
Adam.
Oh, Adam, sorry. All right. Got an oscillator and an AND gate connected together?
Or maybe you've been working with the combination lock that we've been building as well.
Can you explain? Adam, looks interesting. Can you explain what your idea is?
Okay. One diamond, Adam.
Adam, got a few more minutes here. Do you want to show it next time?
Yes.
Looks like you're on a good track, Adam. Are you ready to show it off, Adam, or would you like to show it to us next time?
Yes.
Next time. All right.
It
Right.
opens.
Your idea is that it will do what? Okay. Last chance. Anyone else like to show us their inventions?
Looks like Memo raised his hand.
All right, Memo, would you want to share your screen?
Yes. I already. Wait.
Nice. That looks awesome.
Whoa.
Just I need the last part of here.
Sweet. Yeah, it looks like you have it. It looks like you built the actual lock now. And now all
Yes.
you need to do is connect it to an output. That's amazing. Perfect.
What?
What I need to do in here? I'm just missing this part, the last.
It looks like it's fully built, and then all you can, or what you need to do now is you can connect that torch that's at the end, the very last torch, the one that is on your screen right now. That's going to be connected to whatever output. So now that you have that redstone right there, you can connect it to really anything that you want, and it should be working. Do you want to give it a test run by flicking the levers?
How?
So you go over to the big part on the combination lock at the far end. That should be where you place the levers.
What are you doing? Wait. Like this?
Yeah, right there. Yeah. So if you flick them, does the redstone change on the other end?
No, it don't change.
Oh, I see. So what's happening is if you look at the AND gates, you can see there's a difference between those two and your final one, which is that the redstone is coming too high, so it's getting turned on by the torch. So if you make it go a little bit lower, if you break the wood block that's right there and just make the redstone go lower, then it should be working. And also you need to make sure that the levers down there can turn it on. Yeah, so it looks like the levers are in the right spot, I think. So you need to break the wood that's right next to that bedrock. And yeah, and then it'll make sure that your redstone goes lower. So break all of that wood. Break all the wood, and don't put bedrock there. Just break it and then place the redstone right on the dirt.
Like this?
Yeah, just like that. And then it'll work.
So one other thing you might want to keep in mind, as cool as bedrock looks, typically you don't want to use it with redstone because like the signal from your lever is not actually going to go through.
Oh, yeah.
Yeah. It's like it's a small detail, but it might make your contraption not work right.
Yeah, that's true. Yeah, so you might have to replace the blocks that the levers are on with anything other than bedrock. So just like the wood block that you have right there, place that where the levers are, and I think everything should be working.
Yeah,
cool. That looks great.
Okay. To be continued tomorrow, guys.
Yeah, so remember your mission is to finish that combination lock and then connect it to something. So really whatever you connect it to is up to you.
Wait.
Matthew, Lucian, thank you.
Yeah.
To be continued tomorrow. Oh, I like your cat. What's your cat's name, Adam?
We have a second one. I don't know where is it.
The black cat. All right.
There's a black and white too.
Let's
Beauty.
hear it.
That's a great cat. Thanks for showing off your cat. Nice cat.
Awesome.
All
Just
right.
created something. Can I share?
Show us tomorrow, okay, Adam?
Yeah, keep working on it, and
But
you can share it tomorrow.
It's really fast.
Okay.
This. I keep my secret stuff.
All your stuff is stored in your chest.
Cool.
All right. Okay, Marcus.
All right, sweet.
Well, see you tomorrow.
Marcus, Memo, Adam, we will see you guys tomorrow.
Bye,
Bye.
everyone.
Bye, guys.
Bye. Bye.
Bye.
Bye.
Bye, cat.